All right, in this lesson, we're going to look at particle diagrams. And what particle diagrams are just imagining that we could see with our eyes those teeny tiny little atoms and how they're behaving. So we're going to see that we're going to use little dots and circles and things like that to represent them, a lot in the same way we represented electrons, but here we're going to be talking about whole atoms. And they get a lot easier the more you practice with them. But we're going to use them to represent elements and compounds and see how they actually behave slightly differently. We're also going to get into what's the difference between a pure substance and a mixture. Now, a lot of times people think you can tell whether something's pure or a mixture simply by looking at it. And well, sometimes that's true. Like if you mix salt and sugar, or I'm sorry, salt and pepper, you'll see those little black pepper flakes in there, and you'll be pretty sure that it's a mixture. But imagine if you mixed salt and sugar, it would be much harder to tell. But if we look at the atoms and how they're behaving, it makes it much easier to tell if something's pure or a mixture. So let's look at this. I've got 4 boxes up here, and obviously I want you to make a prediction about what's going to happen. And when we make predictions, a lot of times people are like, oh no, I'm nervous about being wrong. Don't worry about being wrong. Here's what I want you to do is these 4 boxes, some of them represent pure elements. I want you to tell me which 2 represent pure elements and how you knew that. Well, if you said A and D represent pure elements, you're absolutely right. Now, I worry there's somebody out there who's saying, but wait a minute, D can't be, right? I understand this one's a pure element because it seems to represent some atom. They're all red. Color seems to indicate if it's a different color, it's a different atom. That's a pure element. But over here, there seems to be a bond. But remember, as long as they're the same element, let's say they're both fluorines, right? That's telling us it's an element too, right? They're all the same type of atom. Okay, well, if compounds have mixtures of types of atoms, only B or C is actually a pure compound. Which one do you think is the pure compound and why? Well, C is not. C is just a bunch of elements mixed together. Why are they not compounds? Because they're not stuck together. Like look in B, they're all stuck together. So when we say like CO2 or NH3 or something like that, we're imagining those 3 H's attached to the end. They have to be physically attached. So while this is a compound, this thing over here is just a mixture of elements. It's as if I took pure, I don't know what we'd call this stuff, pure gold and mixed it with a little bit of nitrogen and put them together, but it's still just gold and nitrogen. They haven't made any compound. So that's why we want to look at particle diagrams, is because they can show you that having a mixture of atoms does not make them compounds unless they're attached specifically together. And something can be pure, whether it's an element, there's a pure element, or a compound if all of the things in the sample have the exact same organization, so to speak. All right, so I want you to look at these diagrams here. If you were going to look at X, would you say X is definitely pure? Would you agree? But is X representing an element or a compound? Well, if you said element, you're absolutely right. I'm assuming these are all the same atoms. Maybe they're copper atoms or something like that. What about Y? Y is pure. Would you agree they all look the same in there? But is Y representing a pure element or a pure compound? Definitely a compound, because I think the 2 different atoms in here are different atoms. They seem to be attached together. They're not just floating around. And I think that represents a compound. What about Z? Is Z an element or a compound? Now, I think it's pure because they all look the same to me, but element or compound? Definitely compound, right? There's one type of compound in here. Now, there's 5 different molecules of it, but there's only one type. So I think it's also pure. The only mixture in this group is W. W is a mixture of the green thing, which was an element, this other thing, which was a compound, and then a different type of compound. This would be a mixture, whereas this would be a pure compound. This would be a pure element. This would be a pure compound. You get the idea. Okay, so what we're going to do is we're going to look at a bunch of these diagrams and see if we can figure out, is it an element? Is it a compound? Is it pure? If it's a mixture, what's in a mixture of? Are there a couple of compounds in there, or are there a couple elements? So let's look at these, and we're going to go through them kind of one at a time. Let's try this. In A, I want you to tell me, first of all, does it represent a pure substance or a mixture? It's definitely pure. Is it an element or a compound? It's a compound, right? Because there's more than one thing attached together, different types of atoms. Let's look at B. Do you think B is pure or a mixture? It's a mixture. Now, it's because it has two different things in here. Now, those two things in there, are they both elements, both compounds, or do you have an element and a compound? They're both elements, right? The reason is you got that's an element, I don't know, maybe that's two chlorine atoms, and this is an element, maybe it's two bromine atoms, but it's just a mixture of a bunch of elements like that because they're not two different elements or atoms attached together. What about C? Is C representing a pure substance or a mixture? Definitely pure. And wouldn't you say D is as well? And both of these represent elements or compounds? Definitely elements, right? Because there's not different types of atoms stuck together. So you get the idea. A particle diagram is pretty useful for representing what's going on here. All right, let's move me down here. Which of these represents a compound? So does A, B, or C have a compound in there? Well, if you said C, you are correct. Compounds are different types of atoms attached together, which they definitely are there. B is the same type of atom attached together, so B would be an element. But what about over here? There are different types of elements in A. Why did A not turn out to be a compound, even though there are different types of elements? Because their different types of elements are not attached together, right? The blue spheres are never attached to the red spheres. They have to be attached together to make them compounds. So only C is a compound. By the way, while we're here, which of these are pure samples? B and C, right? This is a pure element. That's a pure compound. This over here is a mixture of elements. Let's try this one. Which of these, let's just start with which of these are pure substances. When I'm looking at this, I think all of these look in here the same, all of those look the same, all of these don't look the same, right? We've got a mixture of two different elements here. So C is definitely a mixture. And these don't look the same either. They aren't like either all red spheres or all of these kind of things. I think both C and D are mixtures. Which of these has a compound in them? Now, I'm not saying it could be a pure compound or it could be a compound in a mixture, but which of these has compounds in them? Well, A definitely does. Two different atoms attached together. B definitely does. Two different types of atoms, red ones and white ones, attached together. C does not. There are no compounds in it because all the same type of element are attached together. So these are just a couple of elements. And then this one, yes, it does have a compound. Not the red sphere, but this thing with the red and the white, it seems to be two different types of atoms attached together. So A, B, and D all had compounds in them. What about these? Which of these has an element in them? Oh, I think we already covered this. Definitely C has an element in it. But C is not the only one that has an element in it. What's the other one? D. D, the red sphere, seems to be an element. Seems to be a type of atom that's by itself. All right, now we're going to finish this up with some sort of, you can see I got a lot of stuff on this slide, right? And we're just going to try this out. Now, there's more than one possible answer. In other words, you could choose like A, C, and G or something like that. But what I want you to do is, which of these contains a pure compound? It's got to be a compound, not an element. It's got to be pure. Well, let's see what we thought here. If I come in here, a compound has to be attached together. Look, that's attached. I think A is an answer. That's an element. That's an element. Nope, B is not an answer. C has a compound, but it's not pure. We said it has to be pure because there's another type of thing in here. So C's out. It had a compound, but it's not pure. D, look at that. Different types of elements attached together, and they're all the same type of compound. D would be a correct answer. E is not. Now, I know you're thinking it's pure, and it has things attached together. But remember, to be a compound, they have to be two different types of atoms attached together. So that's out. F is definitely an atom, not a compound. G has some compounds in them. There's one, and there's another. So the problem is there are two types of compounds, but they aren't the same type throughout. Like up here, this was one pure compound. These are two compounds, but it's a mixture. H, I think those are atoms. They look like they're all the same type. I, yeah, because it's a compound, two different types of elements attached together, and they're all the same type, they must be pure. So the answers were A, D, and I. Addy. All right, let's try this one out. Which of these contains a mixture, as in it's not pure? And I don't care if it's a mixture of elements, mixture of two different types of compounds. I don't care what it's a mixture of, but it cannot be pure. There might be more than one correct answer. A is pure. Look at them. They're all the same. D is pure. They're all the same. E is pure. They're all the same. F looks the same. I, everything looks the same. H, everything looks the same. That's a mixture of two different types of compounds. And this is a mixture of a compound and an element. And that's a mixture of two elements. So we've got B, C, and G.